In this video, we are going to talk about Z transform of a sequence. The definition goes like this. The Z transform or Z transform of the sequence Fn is defined as Z of Fn is equal to sigma n equal to 0 to infinity f of n times Z to the power n. If I denote the sum by f of z, then I can write Z transform of the sequence Fn that is equal to capital F of z. Before going to the problem, you have to recall the binomial series expansion which we have learned in our previous videos. The first one, 1 minus x to the power minus 1, that is equal to 1 plus x power 2 plus x power 3 up to etc. infinity. Second one, 1 plus x to the power minus 1, that is equal to 1 minus x plus x power 2 minus x power 3 plus up to etc. The third one, if I have 1 minus x to the power minus 2, then we have 1 plus 2x plus 3x power 2 plus 4x power 3 plus up to etc. infinity. And if I have 1 plus x whole power minus 2, then we have 1 minus x plus 3x power 2 minus 4x power 3 plus infinity. If I have minus sign here and in the exponent, then all the terms in the series will be positive. If I have plus here and with the negative exponent, then you have alternate sign starting from plus, then minus, plus, minus and so on. Let us discuss some of the standard sequence and how we find Z transform for those sequences. Let us begin with Z transform of a to the power n. So let me write the definition of Z transform. In the previous slide, I told you Z transform of Fn that can be written as sigma n equal to 0 to infinity Fn Z to the power minus n. In this problem, in place of Fn, I have a to the power n. So replace Fn by a to the power n in the formula. We will get sigma n equal to 0 to infinity a to the power n Z to the power minus n. So this e to the power n z to the power minus n, I can write e to the power n divided by z to the power n. This I can write a divided by z with the common exponent n. So I have sigma n equal to 0 to infinity a over z the whole to the power n. We know that the series starts from, or the summation starts from the value n equal to 0 until infinity. If I replace n equal to 0, I will get a by z whole power 0. This summation denotes we are going to add the terms. So I have the next term like a by 2, we will replace n by 1. Then we will replace n by 2. So I am getting a series like this. This first one, a by 2 whole power 0, this is nothing but 1. So we have a by z the whole power 1 plus a by z the whole power 2 up to etc. This is z, not 2, this is z. Okay, so this is nothing but in the form of 1 minus x the whole power minus 1. This one we know that it is nothing but 1 plus x power 2 plus up to etc. So in place of x, we have this one a by z. Okay, so if I write in this series, I have a 1 plus a by z plus a by z the whole power 2 up to etc. So this whole thing is nothing but 1 minus a by z the whole power minus 1. By taking LCM, here we have 1, so this will become z minus a divided by z the whole power 1. So this is nothing but z by z minus a. So we are changing this one like this. This will be z minus a by z the whole power minus 1, which is nothing but equal to z by z minus a. So I have concluded that the result of z transform of e to the power n that is equal to z by z minus a. Okay, let us move to the next question. Question number 2, we are asking to find the z transform of 1. So just now we have concluded Z transform of A to the power n, that is equal to Z by Z minus A. So now I have Z transform of 1. That means in place of A power n, I have 1. So this one I can write 1 to the power n. 1 to the power n is nothing but 1. So that means in place of A, I can substitute the number 1. So we have Z by Z minus 1. Question number 3. Before going to question number 3, we have to remember the rule Z transform of n to the power p, that is equal to minus Z times the derivative of Z transform of n to the power p minus 1. So let us discuss question number 3. In question number 3, we are asking to calculate, find Z transform of n. So we have Z transform of n. If you compare this formula with this one, we come to know that in place of p, I have 1. So let me replace p by 1 in the formula. So we will get this one. Then this 1 minus 1 is nothing but 0. We know that anything to the power 0 is nothing but 1. So this z of n to the power 0 is nothing but z of 1. In the previous slide, we have concluded that z of 1 equal to z by z minus 1. Okay, so we have minus z d by dz of z over z minus 1. This minus z keep as it is. Now we have to focus this one. We need to find the derivative of z over z minus 1. So we have z on the numerator and we have z minus 1 on the denominator. So we have to apply u by v, the quotient rule. What is quotient rule? We have to keep v, then differentiate du, minus u differentiate v divided by v power 2. So we have v du minus u dv by v power 2. In place of u, you have z. In place of v, you have z minus 1. So by substituting here, I will get v. So v is z minus 1. Then derivative of z with respect to z will give you 1. Then in the formula, I have minus. Then u. In place of u, you have z. So keep z here. Then I have to differentiate v. So derivative of z with respect to 1 will be 1. Okay. Then we just simplify this expansion. So this will be z. We have minus z outside. Okay. And if I multiply this one, z times 1 will give you z. This will be minus 1. And here we have z times 1, which is z with the minus sign, minus z. So this all divide by z minus 1 the whole square. So this plus z minus z get cancelled. Minus z times minus 1 will be plus z. So we have concluded that the answer is z over z minus 1 the whole square. Let us see example number 4. In example number 4, we have to calculate z transform of n to the power 2. So let me compare once again this problem with the formula. Okay. So we come to know that in place of p, we have 2. So the formula will become like this: minus z d by dz of z transform of n power 2 minus 1. So this n power 2 minus 1, I can write z of n. We know that z of n equal to z upon z minus 1 the whole square. So we will get this one. So once again, we have to find derivative of z by z minus 1 the whole square. So again, the numerator has z, the denominator had z minus 1 power 2. We have to apply u by v method. So here u equal to z and v equal to z minus 1 power 2. So we will get this one. From this and this, let me take z minus 1 outside. We have already minus z outside. So here is z minus 1 and here is z minus 1. So I will take z minus 1 as a common factor. Then the remaining terms are z minus 1 minus 2z upon z minus 1 power 4, because we have 2 in the denominator but in the formula I need v power 2, so this would become z minus 1 the whole power 4. By cancelling 1 z minus 1 and by simplifying, we will get this answer, z squared plus z by z minus 1 the whole power 3. Now we have to calculate z transform of n plus 1 the whole square. So this one, first you have to apply a plus b the whole squared formula. So you will get this one. Then write z transform of each and every term. So we have z transform of n power 2 plus z transform of 2n plus z transform of 1. So this one we keep as it is. From the second term, let me take 2 outside since 2 is a constant term, and here this one will be z of 1. We know that z of n power 2, that is equal to z power 2 plus z minus 1 the whole power 3 plus 2 z of n, I can write z by z minus 1 the whole squared plus z of 1, I can write z by z minus 1. Question number 6, find z transform of n minus 2 the whole squared. So we have to apply a minus b the whole squared. So that is equal to a squared minus 2ab plus b squared. We have given n minus 2 the whole squared. So in place of a, I have n. In place of b, I have 2. So if I expand, this would be n power 2 minus 4n plus 4. Then once again, we will take z transform of n power 2, z transform of minus 4n, z transform of 4. From the second term, take 4 outside. So you will get z of n power 2 minus 4 times z of n. From the third term also, if I take 4 outside, we have 4 into z of 1. Then we know that z of n power 2 is equal to this one. We also know that z of n is equal to this. So we multiply this by 4. And finally, z of 1 is z by z minus 1 multiplied by 4. So this is my final answer. Question number 7. We are asking to calculate z transform of e to the power an. We know the rule z transform of e to the power n, that is equal to z by z minus a. So this one I can write z transform of e to the power a to the power n. If I compare this with this, we come to know that in place of a, I have e to the power a. So how I can write this one? This is simply z by z minus, if it is a, I will write a here. So if it is e power a, then I can write this as e power a. So I have concluded that z transform of e to the power an is nothing but z by z minus e to the power a. These 3 problems for you to do as an exercise problems. Check it. See you in the next video.